In 4.1.2, we talk about the voltage of batteries, and it's supposed to be a uniform distribution between 1.43 to 1.60. So this is for each individual battery. Its voltage follows a uniform distribution from 1.43 to 1.60. Now it's saying if a box contains 50 batteries, what are the expected value and variance of the number of batteries with a voltage of less than 1.5 volts? So as soon as you see that number, anytime you see the number, you need to start thinking, okay, this would have to be something with a discrete distribution. So go through your list of discrete distributions and try and figure out which one it would be. You always start with binomial because that's the most common one. So for binomial, you have to check 4 things. Okay. So each thing has to be either like a success or failure. It has to have only 2 options. So in this case, we could either be less than 1.5 or greater. So 2 options. Each battery needs to not affect each other. So each battery is independent. Well, that makes sense. The batteries shouldn't really affect each other's volts. You need to know in advance how many you're looking at. We are looking at 50. And you need to look at the probability of whatever you're interested in. So in our case, the probability that a battery is less than 1.5 volts. Now, that should be the same for each battery. It should be the same, so we'd be good there. So we know it's going to be binomial. But let's then take a sidebar. What is the probability that one battery is less than 1.5 volts? So again, this is just for one battery. Well, when you talk about one battery, you're back at the uniform distribution. So for a uniform distribution, the probability that x is less than something, we will want to use the CDF. So capital F of x is equal to x minus a over b minus a. So in our case, our x we're interested in is 1.5. Our a value is that lower bound of 1.43. And b is our upper bound of 1.6 minus our lower bound of 1.43. So this gives me 0.412. So when we look at just one battery, there's a probability of 0.412 that it's going to have a voltage of less than 1.5. Now we're interested in a box of 50 batteries, what happens with the number of batteries with a voltage of less than 1.5. Okay, so now for one battery, that's the probability of being less than 1.5. Now if you're interested in the number of batteries in the box, we know it's going to be binomial. N is going to be 50, and P equals 0.412. You'll notice in these sections that our textbook really likes to combine distributions, so you have to find a probability of something, and then you switch over to using the binomial distribution to find the rest of it. So now it said, find the expected value and variance for the number of batteries with a low voltage. So now we just need to find the expected value of x, but we do that with the binomial. Okay, because we're talking about the number, and so that was the binomial. So we'll use the binomial formula. So n times p, so 50 times 0.412 equals 20.6. For the variance, that's n times p times 1 minus p. So 50 times 0.412 times 1 minus 0.412, which gives me 12.11. So that's your variance and your expected value. Again, the reason we had to switch from using exponential is because we're now looking at 50 batteries and not just one, and it said we're interested in the number of batteries, and that's what told us, okay, switch over to binomial.